Hello everyone and thank you for watching. We continue with the section 2 of this paper, top joint examinations. So question 17 is on three-dimensional geometry. The diagram shows a model of swimming pool ABCDEFGH as shown below. The measurements are given: AB 50 centimeters, BC 80 centimeters, CH 40 centimeters, and BG is equals to 20 centimeters. So the diagram is them. The first question: calculate correct two decimal places the length FE, that is 1, 2 marks, FE. So where is FE? You can see where FE is. So there we have FE. So how do we get that length? Looking at what we have here, if we are able to draw a straight line, from F all the way to that point, you notice me draw it again. So if we're able to draw that line there, and that is 20 centimeters. So also this height here is 20 centimeters. And see, since the whole of this height is 40, it is the same with this one. And this one is 20. So this one means this will be 20 as well. And this will be 90 degrees. So this one 20 centimeters. So you can see now we have a right angle triangle. Then this length here, F to that point, is the same with this length, that is 80. So this length there will be 80. That will be 80 centimeters. So you can see now we have a right angle triangle, and we'll be able to use Pythagoras theorem to get FE. FE is the hypotenuse. So therefore FE using Pythagoras theorem will be given by the square root of 80 squared plus 20 squared. And this one, when you use your calculator, you'll get this one correct two decimal places. You'll get 82.46 centimeters. That is the part 1. We go to part 2, the length AC. So we identify where is AC. So AC is this length there. We'll have to draw it. So AC is that length. And that one will be quite easy to get because we have this base, or these angles are 90 degrees here. So this angle here, this is 90 degrees. And we are going to use this triangle ABC, that triangle. You can see AC will be the hypotenuse as well. So AC is the hypotenuse when you consider this triangle that you can see here. So AC will be given by the square root of 50 squared plus 80 squared. And this one gives correct two decimal places. You get 94.34 centimeters. We go to part B. Determine the angle made between plane FGHE and ABCD. That is the angle between two planes, FGHE, FGHE. You can see that plane. And the base is AB. So when you look at those two planes, they are not intersecting at any point. There is no line of intersection of those two planes. So FGHE and ABCD, they are not intersecting. So you have to translate one plane. And the plane that you're going to translate will be plane ABCD. So we translate plane ABCD so that it touches the other plane FGHE, and it is going to touch that at the line FG. So this is what I mean. So allow me to rub something here. Let me rub so that I can translate that. So let me translate it so that when you translate it, you'll have something like this. You will have something like this when you translate it. So now you can see. So this plane ABCD, I've translated it here on the other plane. So I've translated that plane to get F. I will name these. Let me name this one as M, and this one I can name it as Q. So I've translated it to get FGMQ. So that is what I've done. So when you look at now the angle, when you look at the angle that we have, the one that we require is this particular angle. Now the line of intersection of the two planes will be FG. After you translate the base ABCD so that it meets or intersects with the other plane FGHE. So this is the line of intersection, and this is the angle here. So that is the angle that we need. And how do we get that angle? You consider this triangle here. So you have this triangle GHQH. So we have this triangle with the measurement 80 centimeters, and then this is 20 centimeters. So you can use trig ratios to get that angle. So that is the required angle. So this is the required angle between the two planes. So this is how you're going to get it. So we shall use tan of theta is given by the opposite side, which is 20. 20 is here, divided by the adjacent. The adjacent is 80, like that. Therefore, theta will be given by the tan inverse of 20 divided by 80. And this one gives 14.04 degrees when you work it out. So that is the angle required. We go to the other question, part C. Given that N is the midpoint of EH, calculate the angle between plane A and B and the plane ABCD. Given that N is the midpoint of EH, N is the midpoint of EH. So N here. So that is the midpoint. So I'll have to clear. So let me clear everything here so that I can illustrate that. So N is here. So N is the midpoint of VH. So you're supposed to calculate the angle between A and B and ABCD. A and B. So let me complete A and B. So we have A to N, and then B is there. So now you see that plane A and B and the base ABCD. So the required angle will be this angle here. Look at the point of intersection of the two planes. It is AB. So the required angle will be this. This will be the required angle. That will be the required angle here. So you can see you're forming a right angle triangle. Look at the two planes ANB and ABCD. Look at the point, line of intersection of the two planes. That is where the angle will be made. The line is here. So the required angle to get it, you have to draw this line perpendicular to this plane, and then it is intersects with the perpendicular line from the other plane at this point. So this is the required angle. Now the measurements, this will be 80, and then this one will be 40. So that right angle triangle, you just use trig ratios. So tan of theta. So tan of theta is equals to the opposite side, which is 40, divided by the adjacent. The adjacent is 80, like that. And this will be given by, you get the tan inverse of 40 divided by 80. And this will give, when you work it out, you get 26.57 degrees. So that is how you're supposed to solve that question.